Hello and welcome to this session where we are looking at the machine learning service, which is an element of the Autoscholar Advisor system. In one of the previous videos in the series, we showed how to download data through the Autoscholar or through the Scholar Cloud aspects of the Modern Scholarship program. And now we are looking at undertaking machine learning on that data. So if you go ahead and run the machine learning service, and we will show separately how to upload the data to the machine learning service. So if you go ahead and upload the data, then automatically the service will go ahead and perform the machine learning, and you'll be shown under boosting results these kind of summaric results here. So it's showing us that we have 71 data points in this data set. So we are in effect, in this case, we are looking at a single course, and it is a previous year, so a previous year's records of a given course, and we are interested in whether we are able to determine which students will pass and which students will fail. So because it's a previous year, we do know which students eventually do pass and which ones fail. So here we have these two graphs. It's showing us the classification into passes and fails and so on. It's showing up here the number of data points. That's basically the number of students for whom we have records in that year. It's showing here the number of features that were used for the training. So in this case, we are predicting whether there'll be a pass or fail entirely in terms of the assessments in the course. So that's why there's a low number of features. We'll show in a separate video when you combine student data with that. But we'll see just now, even the performance data in this course is quite strong in terms of developing our model. And then there are some other values that show us the Pearson R correlation. So you can see quite strong correlations here in terms of predicting student performance. So down here we have some of the metrics that are commonly used in machine learning. So you can see the accuracy, the most obvious one, then the recall as well. So recall is sometimes a more important measure than accuracy, because in the context of identifying at-risk students, it's sometimes more important to conservatively estimate which students are in need of support, which means you don't mind advising more students than actually do need it. So it doesn't matter if there's a student who has been advised to go for more support. If that student was going to pass anyway, you would rather advise as many students as possible to go for support. At the same time, of course, it's not always possible to send everyone for support, but you don't want to miss students. So if you only take an accuracy-based approach, you might not get all the students. If you try to optimize only for accuracy, you might miss some of the students who really need that support. Whereas if you take a recall-based approach, it's much less likely to happen. In this case, it doesn't really matter because we were able to predict with 100% accuracy, or to classify with 100% accuracy. And these are the so-called boosted results. You can see some other metrics here, the number of students who actually would have passed anyway, or these are the numbers of students who were not at risk, those were at risk, and so the system has managed to perfectly classify these students. That's after boosting. So boosting is an approach where if you have multiple estimates of a classification, so we are trying to classify which students are at risk, which students are not at risk. If you have multiple models that try to estimate which students are at risk, then when you take an approach of boosting, it in effect queries each model. So if you have multiple models, it checks each model and then allows each model to vote for which students would be at risk. So in our case, we use as many as 6 models. So you can see here 6 names of machine learning algorithms. And if you take, for instance, the decision tree classifier, this doesn't perfectly classify the students. It's pretty high. It's in the high 90s, but it's not 100%. So this captures, so it doesn't get it right in 3 of the students' cases. And then you'll see other models are not as good as that. Well, that's actually slightly better. Here you can see slightly worse, and then here this one is actually much worse. Your performance is pretty weak in this case, and then yeah, this one is the worst of the lot, I guess. But the important thing is that if each of these models gets it wrong in different places, then when you boost all these results, when you allow each of these models to vote, if they get it wrong in different places, then the boosted results give you a much better overall performance. So that's why we get that 100% there. So that's how to look at the machine learning here. You first run multiple models on your machine learning, on your data set, and each of these will be able to classify the students to different extents. And then automatically after this completes, after it's run through all these algorithms, it will go ahead and try to let each one vote and then give you the final scoring of that machine learning model. You can also see the confusion matrix here, the receiver operating characteristic curve, and the basic metrics about the data. So from this dashboard, you'll easily be able to understand how this data looks and be able to determine whether this is a useful machine learning model.